How's everybody holding up so far?
Pretty good.
Hope we're not going too fast for anybody yet. I hope. Is that the case?
I don't think so. I'm okay.
Good. Good. So yeah, so I noticed that a lot of people are wanting to switch sections. If that's the case, it seems like a lot of people have signed up for one section thinking they were signing up for another. A lot of the students so far have been like, hey, I thought labs was supposed to be at night and it's in the afternoon, and like, wrong section. If that's the case, yeah, just send myself and Dr. Gagreb email, and what you'll have to do is drop out of one section, and then we'll give you an add code to add to the other one. It's not that difficult. So if you're having trouble with that, okay. Is there anybody in that situation here who would rather be taking the lab during the evening class?
Yeah, I thought I signed up for the evening class,
Yeah.
but I mean, I don't know. It depends on how I work, because I also work, but this is not a bad time for me. So I don't know. I might switch. I might not.
Either,
But it's
yeah.
good. It's good.
Whatever works for you. I mean, we're supposed to be, helping you guys. So whatever
Yeah.
works. But if you need to do that, let us know, and we can just switch you from one to the other.
Okay. Thank you.
But I
Hello,
think,
Professor.
yeah. Mm-hmm.
Are you gonna post a recitation later? Because
Yes.
I think I missed it. I have the time difference.
Yeah.
I'm back in my country. So.
Everything will be posted by the end of the week, because I have to. They're fairly big files, and I've got to edit them and then submit them to YouTube. It takes a little while. So yeah,
Okay.
but they'll be submitted by the end of the day tomorrow.
Okay, thank you.
Hey, Rich. You want to say hi to everybody? This is Roger.
Hi.
He's a chemist himself, right, Raj? Yeah, sort of.
Wait, Professor?
Yes.
Wait, so if we were in that situation, with the class and the times, wait, what did you want us to do?
Oh, the thing is, if you would rather be in the section that has lab and recitation during the evening, you'll have to switch from this section to the other one. And if you need to do that, just send me and Dr. Gagreb an email, and so we'll have you drop this section, and he'll give you an add code for the evening section. Okay?
Okay, yeah, because it actually conflicts with one of my classes, another class I'm taking.
Okay.
Right now, so yeah.
Yeah, just send us a note. We'll try and take care of it as quickly as we can.
All right, thank you. Yeah.
Yeah.
One more question.
Sure.
You said all the labs are mandatory. But I wasn't at the recitation yesterday. Are you gonna deduct any points?
Nope.
Okay, thank you.
No, as long as you get the assignment submitted on time, it's not a problem. Yeah, I mean, I realize that this is all kind of craziness right now, and yeah, people's schedules are all messed up, and so yeah, you're not going to be punished for missing a recitation.
And the lab reports, do you have an example?
Yes, actually, King segue. Yes, I was going to begin by talking about that. So on the, you can see hopefully you can all see the Canvas page on the left side of the screen here. So if you scroll down to Canvas Assistance, I have doing lab reports. And these are just sort of generally the way I'd like to have lab reports submitted in these different sections. So just, first of all, the title, what it is you're doing, the date and your name. And then the first section after that should be just like the purpose, which would be just a brief, really brief response to the question, like, why are you doing this experiment? What's the experiment about? Just one or two sentences is really all you need. And then the next section would be the procedure. So the procedure, don't write everything that's in the lab guidelines. Don't write the whole thing down. I know what the procedure is. I just want you to give me a brief summary. Maybe 4 or 5 sentences about what you did. Okay, and then then next would be the results. So you should have data tables, graphs if called for. Here you would write in anything like, let's say there was we were doing like a chemical reaction or something. You noticed a color change. You'd write that in the results. When I added chemical X to chemical Y, this color change happened, or I noticed that the heat was released, or it got cold, or something that happened there. All that kind of stuff. If you had a problem doing the experiment, let's say something didn't work, or you got a result that you didn't expect, or you made a mistake. Let's say you were doing the experiment at home when we got our kits or something, and you dumped half of it on the floor. That's a good place to put that in there, because really what we're looking for is if you had an issue with doing the experiment and it affects your results, just write that down. You're not going to lose points for saying, I didn't get the expected results if you had a really good excuse for that happening. My dog jumped up and, ate my experiment or whatever. You would just put that in there. And one thing you should notice is that a data table and a graph should both always have titles. Just saying data table is not sufficient. You have to have data table 1, and then tell me, what's in it? Why is there a data table? What's the data in there? And the graph should always have a title as to what is this data? Why, what's the purpose of the graph? And the axis of the graph should both have titles. So the x-axis and the y-axis should both have titles and units on them. Just giving a graph that has a bunch of points on it, with a straight line through it, doesn't tell us anything. We need to know what the units are, what the relationship is, and why the graph is there. And then finally, the conclusions. So the conclusions would be, well, after I analyzed the data, I made the graph, I looked at the relationship between X and Y. What did I learn? Did I get the expected results? Why didn't you get the expected results? Did you learn anything different from doing the experiment? And you could also put the answer for the post-lab questions in this section as well, because those are basically conclusion type questions. So are there any questions about doing the reports?
I have a quick question.
Yep.
Oh, sorry. Go ahead. You can go first.
I was just asking, do we submit it with the lab or separately?
That is the lab report.
Oh, okay.
That is it. Yeah. So so you would just go to where are we? You just go to assignments, and then there should be a place to submit a PDF or a Word file or however it is you're going to be submitting it. Remember, it's really nice if you can get it all into one file. That really, really helps. Because a lot of times, if you submit each page separately, the order of them gets mixed up, and then it's really kind of hard to follow the flow of the report from the beginning to end. So if it's all in one file, it's much, much easier to do, that you get to determine what comes first and what comes last. Any other questions?
So we
Actually, I have a-
submit.
oh, sorry.
Go ahead.
Go ahead.
So we submit the lab report along with the lab worksheet that we're about to do, or just only the lab report?
Well, I would like the report by itself. If you want to do the report on the worksheet, that's okay, but I would like to still have, so that would have the title, the date, and the name. I'd still like to have a purpose written out and the data tables and whatever, and the conclusions at the end. So you can include that. If you just want to write that right directly on the sheet, that's fine. You can do it that way.
So we don't have to include the actual worksheet. You just want the lab report.
Yeah, either way, you can either do it on the I think Dr. Gagrab put it this way so you could do it directly on the worksheet. If you want to do it that way, that's okay, but you will need to include purpose, procedure, conclusions, and whatever other results that aren't included on the worksheet. Like if you had a problem doing it, put that. You can include that at the end of the worksheet.
Okay, thank
Either
you.
way, you don't have to submit both, is what I'm saying.
Okay.
But I just want to make sure. So if I just create lab reports separately, but still I have to submit also my work in worksheet. Is that correct?
No, one or the other. What I do want is like everything that's on this doing lab reports page with the different sections. I want that in there. So if there's no place for conclusions, I think you need to add that. I mean, you can answer the post lab questions directly on the sheet, but there needs to be your summation of what your conclusions are somewhere.
Okay.
Yeah.
Actually, I have a question about the recitations. Is there like a certain format you want for those or no?
You can do them. You can either print them out and do them right on the sheet itself, or you can just write the answers down on a piece of paper and submit that.
And you also want to work for that, right?
Oh, excuse me. What do you mean?
Like to show our work.
Oh, definitely. Yeah,
Okay.
yeah.
And we can just take a picture of it and submit it, right?
That's
We
the way.
write it on paper.
That's
Okay,
the way.
thank you.
Yeah. In fact, you always have to show your work. Just writing down what the answer is. I don't know if you did that or your friend did that or you looked it up online or where it came from. You have to demonstrate that you know how that question works. So yeah, always on recitations or on tests or really anywhere, always show your calculations.
I have a question.
Mhm.
On the screen that you have right now that says online lab number 1, for
Mhm.
example, on that screen, on that page, we can write in the purpose on the right side after the measure? Or when you're saying one report, as in like we could do it on that page, or you want us to type it up?
No, you don't necessarily have to do that. I mean, that some people do that. But yeah, if you just want to do it on the sheet, you could write down what the purpose is, or you could just copy this whole thing to Word, and then you could type in, you could format it up any way you want.
Okay, but we don't have to include like the instructions. We'll start from like, let's say, where you have the tables. That would be considered as part of the
Sure.
right?
Sure. But then you would have to give a brief summary of the procedure.
Okay.
Yeah, I don't want the whole thing. Just a brief summary.
Okay.
Yeah.
And for the lab report, do you prefer handwritten or we can type?
Well, everybody prefers typed. I mean, come on. But if you have really good handwriting, do it in pen, by the way. Pencil does not work very well. It doesn't scan very well. When you take a picture of it, it doesn't come through very well. And it's good practice, because if you are going to work in a lab, you cannot, like any lab, you cannot take notes in pencil. It's actually illegal. When I was at UCLA, we got this big government grant from the National Institute of Health. And so any of my lab notebooks had to be in pen. And if they weren't, we would have been, hauled before some tribunal, because they don't want data being erased and then replaced. If you make a mistake, that's fine. Just cross it out. You'd initial, and then you would write in what you did. So, because what they don't want is like sort of, if you're going to write an article or publish a scientific paper, they don't want you changing the results to fit your hypothesis. You know what I mean? I mean, you get the results are the results. You can't change them after the fact.
Okay, regarding the graph, do you have a specific format for the graph? Because I know in Excel there are many form of the graph, or it doesn't matter.
I don't know. Is there a graph for this? I don't think there is a graph for this particular experiment. But in general, if I can, let me get change the sharing. So if you're going to make a graph, so you've got your x-axis here, right, and your y-axis here. And this is what we call the independent. This is the independent variable. Meaning you are independently varying it. You're changing it. So if you're looking at the effect of, let's say, pressure on volume, let's say you're doing a gas experiment, you're changing the pressure and you're seeing what the effect is on volume. The pressure would be here because you are varying the pressure. So you'd have P on the x-axis and you'd make sure that it was in you'd have some sort of unit like atmospheres. And then Y would be the volume. And you would have units like liters. And then so you're varying the pressure and you're seeing what the effect is on volume. So this is the dependent variable because it depends on what X is. And so then you would get you plot your points, let's say they're here, and you'd put them together with a line, whatever that line looked like, and you give it a title like effect on volume, by changing pressure or something like that. And you give like, graph number 1. Well, hopefully it keeps running away from me. Hopefully it would be a little neater than this. Yeah, so dependent variable is the Y. That changes dependent on what you're doing in your experiment. X is the independent variable. That is the whatever it is you're changing in the experiment. You would join them together. Either it's going to be a straight line or some sort of curved line or whatever. If you do it on with Excel or some other kind of graphing, you would put the equation here, like y equals mx plus b. Give the y-intercept and the slope there, and you give and if it was a straight line, you would give some sort of r squared, which would tell us how close the line is to perfectly straight. Okay? All right. Let's go back. All right, so any other questions before we have a look at the experiment today?
I actually have one more question on the lab report, because for the post lab, since like most of the questions you have to like show your work, would we be able to like do those on paper, like just the post lab? Because like those are like show your work problems, right?
Yeah. So you don't just write a number.
Yeah, I'm saying like I think it might be easier to do it on paper for like the post lab.
Okay. Yeah, I mean that's the way I've always done these sort of lab reports, is to do it separately rather than writing it down on some other piece of paper. But I think Dr. Gegreb wanted students to have the option of doing that. So either way you want to do it, it's fine with me. But yeah, you always show your work, like I mentioned before. You always have to show your work when you're doing any sort of question, whether it's in a lab report or a test or a recitation or exam or anything. Always have to show your calculations.
Is the due time for lab report the same of the post lab or no?
I'm sorry?
The due time submission for lab report is the same day time for post lab?
It's a week. Yeah, it's all due at the same time.
Okay.
The post-lab questions should be part of the lab report. I would put them in the results, like over here. I've got them in the like section 6 in the results. If you want to do them on the page, yeah, just you know, put them, fill it in where on the sheet, you fill it in wherever it is. There's a space for it, but it all goes together. So anything else?
Will you always be providing the lab report sheets?
Yes.
We won't ever have to like start making our own graphs entirely?
Oh, you'll have to make your own graphs entirely. Yeah. It's not all going to be pre-cut out for you to do. Yeah, I mean, if I ask for a graph, you're going to have to make it either hand drawn very nicely or pasted from Excel.
Yeah, but we don't need to have like a fully fleshed out lab notebook, right? Like normal.
Well, yeah, that's the weird thing is that, since we're not actually physically going to be in lab, you won't need a lab notebook for like the first time ever. Generally, you want to have a lab notebook that you're writing everything in pen. But since this is virtual, there's not really much point doing that. So, you can keep notes wherever you want, but then they have to go into a formal report. So all your results, all your graphs and tables and everything have to be in the report. And if you're going to do it by hand, it's got to be neat, using a ruler and everything else to make graphs, and charts, and that sort of thing. And they're due a week after the lab. So this report will be due next Wednesday.
I have one more question.
Mm-hmm.
So if we do it typed and then we get like, we don't do it by pen and we have to cross it out, do we cross it out or we just like delete it and then retype what we got?
You would just retype it. I mean, what I was talking about is if you had a lab notebook, if you had a lab notebook like we normally do, basically you're not allowed to take notes in it in pencil. So you'd write everything in pen. And so if you were writing down your results, let's say you were doing an experiment, and your lab partner says, it's 13.36. And you go, okay, and you write down 14.36. And he goes, no, it's 13.36. Oh, oops. You would not erase it. You would cross out 14.36 and then put your initials on it and then write in 13.36. So I know that you wrote down 14 and you made the correction.
Okay.
Because that's how it works in a real lab.
Okay, thank you.
But since this isn't a real lab, we're not going to be doing it that way. But I just want you to know that's the way it's done, in the real world.
Mm-hmm.
Okay, shall we try this thing?
Yeah.
Yes.
All right. So here on the right side here, I've got the sheet that was given out. So basically, this was going to be the first experiment you were going to do anyway, determining the density of things. And so we found a couple of websites where you can actually do this virtually. What's going to be tricky is that does everyone have a Adobe Flash on their computer? If you don't,
I do not.
Ooh, yeah, that might be hard. So if not, sort of just watch what we're doing today, and maybe you could install it afterwards, and then try it. We'll just sort of just go over what it should look like. But I have noticed that I tried an experiment last term using Java, and I noticed that a lot of people didn't have Java installed on their computer for animation. And when they tried to install it, their computer freaked out and said, what is this virus you're trying to put on our computer? And they wouldn't let them do it. But I think most people have Flash, and usually it sort of just sits there in the background, and then when it's time to use it, you can enable it. So let's just try that, okay? So let's just start with let's just start by looking at the instructions for the density lab. So let's blow this thing up. So the first thing we find out, and this was something we sort of talked about in lecture yesterday, was about significant digits and making measurements. And one of the things you have to do in this experiment in particular is you're going to have to estimate what the volume that you're displacing. When you weigh something, when you're taking the mass of it on a scale, it's going to give you precisely what the mass is, and however many significant digits that the scale's been set up to deliver. In this instance, when we're measuring volume, we're filling up a graduated cylinder or something like it, and you can see that it's got gradations on it. But what if your water level is in between those two gradations? And so it gives us a sort of look at, here we go. Here it gives us a look at that. So let's have a look. So here is the graduated cylinder. And so we fill it up with liquid, and here's the close-up view right here. So you can see that there's 10 gradations between 40 and 50, right? Can everyone see that? So here's 50 at the top, there's 50, and there's 40, and that there's 10 gradations in between, right? So we'd have to, each one of those is a milliliter. So all we can say right now that it's more than 40, but it's less than 50. So if we look more closely, say it's 1, 2, and it seems to be right on 3. Now, does everyone know what a meniscus is? Have you heard the term meniscus before?
Yeah, it's like
Yes, no?
Yeah.
Yes.
Okay. We'll learn later why there is such a thing as a meniscus. It has to do with the shape of water, and I told you I'm going to bore you to death with how cool water is. But anyway, water, because it likes to climb up the sides of any sort of container that it's in, will have a curved, so this is my graduated cylinder. The edges of it are going to curve up against the sides of the cylinder. And so what you wanted, so we're not going to have a completely flat surface. So what you have to do is go look at the bottom. So the bottom is right there. So basically what you would do if you were actually in the lab, you would get down eye level to where the meniscus is, get right down there and look right through it and see where does it line up with, what's the closest thing, what's the closest gradation it lines up to. And here it's not, you can't really see it very well. I mean, it's sort of, just erase the stuff. When we zoom in, I don't know if we can see this very well, but let's see if we can. Yeah, unfortunately, yeah, whoever wrote this, the arrow on the meniscus kind of messed it up. But if it's directly on a line, what you would do is you would say it's 40 and then go up 1, 2, 3. And if it's right on the line, you would write down it is 43.0. So remember, the first two numbers you're actually reading. You're reading right off of the cylinder. You know it's 40. You know it's at least 43. It might be a little bit more, or it might be a little bit less, but it's around 43. So you're actually reading those. This last number, that's 0, you're estimating. You always, always estimate the last digit because it's going to be in between two of the gradations, or it's going to be so close to one of them that you can't tell if it's on it or not. If it looks like it's right on it, you put a 0. If it looks like it's right in between two gradations, you would put down 43.5. But all of these numbers are significant. Both the 43, which you know is the case, and the 0.5, which you've estimated. So you would have 3 significant digits from reading this, even though you estimated the last one. And that's really crucial because we always estimate, if we're taking a measurement ourselves, we always estimate the last digit because there's some uncertainty about it. So we take our best guess. If it's a little more than halfway, we say it's like 0.7 or 8. If it's a little less than halfway, we say it's like 0.2 or 3. And if it's pretty much halfway, we say it's around 0.5. But it's basically, it's your call. It's your decision to make. What do you think it is? And if you were working with your lab partner, which you normally would do, well, I would recommend you both have a look at it and you'd write down what you both think it is and then take the average. That's even better. So if one person thought it was 43.5 and the other person thought it was 43.3, then you'd say, okay, 43.4, and then shake hands. And that's what your measurement would be. Okay. All right, so let's go down a little bit. And so here's the question right here. So let's zoom in on this one. And you guys can answer this yourselves. So here, what would you say this measurement is?
56.0 ml.
Okay. So we know each one of those gradations is 1, so it's 51. So, and there's usually a larger gradation halfway, so that would be 55 right there, that large gradation. So one more is 56, and you're right, it looks like it's right on. The bottom of the meniscus looks like it was right on. So yeah, I would say 56.0, but that's not a correct answer, is it? If you write down 56.0 what?
ml.
Milliliters.
Mm-hmm. Exactly. Always have a number and a unit. A number without a unit is just a meaningless number. And I will keep saying that over and over and over. All right, so let's look at the experiment itself. So you can read the background. We talked about intensive or intrinsic properties yesterday, and we learned that density is one of those things that's intrinsic to a substance, to an element or to a compound. It doesn't matter how much aluminum I have. If it's pure aluminum, it's going to have the same density regardless if I have a gram of it or a ton of it. The density is going to be exactly the same. And in fact, you can use density, and you're going to use density in these experiments to actually determine the identity of things. So if you measure the density of a piece of metal, you'll notice when you do the experiment, and if you looked up the density of different things, most metals have vastly different densities all over the place. And so you have really, really, really dense metals, like lead is really, really dense. And then you have aluminum, which is not. And copper is a little bit more, and tin is a little bit less. It's all steels have all different kinds of densities, but it's very specific to the kind of compound it is. And just based on color and density, you can pretty much identify all the metals, all the pure metals anyway, because they're quite different. Anyone know what the densest metal is? You're not going to know, but osmium. Anyway, so density, mass over volumes. Let's go to the first website. And I did mention, I added this here make sure the Adobe Flash Player is enabled. So let's go to that site. You can actually just right-click right on this, and it will take you to the site. Now, where is? Okay. So here's the site. So does everybody have this? Was everyone able to get there? Or are you having a problem?
I got it.
Got it.
Okay.
I need to download it.
You need to download Adobe?
Yeah.
Yeah, me
Okay.
too.
Yeah, I can give everyone a few minutes to try doing that, because yeah, it'll be. I don't think it'll be a problem. I don't think it's much of a problem as Java is, but it could be. What I'm going to do, I'm just going to refresh that so we get back to the beginning. Okay. So let me know if you're having an issue with Flash still. Hopefully you won't have to reboot your computer or anything like that. This is actually a good PhET, P-H-E-T, at Colorado is actually a good place to go. They have lots of different simulations of things to play with, all sorts of different things. I'll put a link to some of them on Canvas when we get to them. But yeah, it's a really good place to give you an idea of, like, when we talk about, you know, different intermolecular forces and electrons and all the different kinds of things. You can play with these simulations and see how they actually work. Because I learn by seeing, by, you know, using my hands. So I tend to like doing these sorts of things. So has everyone managed to get to it at this point? Anyone still having an issue?
All good.
All good. Excellent. Love to hear it. All right. So the first thing we're going to do is look at wood. And obviously, there's going to be a whole bunch of different kinds of wood. There's some wood that sinks, and there's some wood that floats. This is sort of general wood. So, you know, piece of pine or something like that. And so here we can play with the mass and the volume. But what you're given basically to start is we can have styrofoam, we can have wood, we can have ice, all sort of different things to look at. We're going to start with wood. Now, you can just write down in your data table the mass and the volume, and then the volume when you the water displaced. So that would be the initial volume. So if we take it out of the water, what's the initial volume of the water? And then when we drop it back in, what's the final volume?
(101.76 liters).
Yep, I think it asks for mils. So you need to convert that to mils. Or you could change the initial and final volume to liters if you like, and put it in liters. You're free to do that. But we're sort
Are
of
you going to be writing the data down, or we should just write it down ourselves?
You should be writing it down yourself, actually.
Right.
Yeah, that is kind of the point. I mean, you're going to be doing this. I mean, I'm basically just going to take you through it and show you how it works. But as far as actually doing the experiment, you guys are going to be doing that, right? I'm just sort of here to show you how it works. But as far as doing the experiment, I'm not going to do the whole thing and like take all the numbers down and you write them down. That's not the point of doing an experiment, is it?
Professor, I couldn't download the Flash player.
You can't download it?
Yeah.
So what do you get? What error message are you getting?
It gives me at least I have 8 players, Flash players.
It says you have Flash Player?
I should download Flash Player 8.
8, okay. Did you do that?
It doesn't work.
I don't understand. I mean, it won't download, or? Did he give me more information about it doesn't work? What do you mean?
Erica says that she needs to allow it, and if it doesn't work on Chrome, she needs to try Safari.
Oh, yes. Yeah, that's true. There may be some browsers that it doesn't work on. I'm using Chrome. It works on Chrome just fine. It probably should work on Safari, I would think, because that's the main browser on Apple's. Yeah, you may have to change the browser you're on. That's a really good point. But I know it definitely works on Chrome. I'm running Windows though, so I'm not sure what the situation is on Apple. Which browser were you using? So whoever was having an issue with it, which browser was it? Guess they must be changing the browser now. Okay, we'll keep going. And
Okay.
what I mean, I'm recording this, so what I'll do is like this will be put up at the end of the week. If you're still having an issue, try a different browser. Try the latest edition of Adobe, and if that still doesn't work, then yeah, probably ask a friend for the data, and then write the report if nothing else works. But we are going to have, but since we're going to be doing a number of these, we're going to have to get Flash to work at some point. All right, so we write down the mass, write down the volume, and then the volume of the water, initial and final volume of the water. The volume of the block is given up here, right? This is the volume of the block in liters. And then you would calculate the density of the block. And we're going to do 3 different trials. So you do 3 different trials. You change the mass. Now we would change the mass to, let's say, 3.45 kilograms. Take it out of the water. Dump it back in. See what the volume of the water that's displaced. Okay, so we're looking at the volume of water that's displaced. Goes from 100 to 103.45. So the displacement volume would be 3.45 liters. Okay. Interestingly, the same as the mass. Wonder what that has to do with anything. So, and then change it again to maybe even something smaller this time. Take it out.
So this is trial 1, right?
Yeah. So you do three trials.
For 3 different materials, or?
No, same material.
Okay. So like, what would we be changing in each trial?
The point of doing 3 trials is to sort of basically prove that no matter what the mass of the material, the density stays the same. Basically, you're proving that density is an intrinsic property.
Okay.
Yeah. Basically, you're proving that. If you want to do another one, you can do another one. You just add trial 1, trial 2, trial 3, and do another one. Do brick. Let's go over to brick. Take that out. And then try 3 different masses of brick and chuck them in. See how much water it displaces and what the mass of the brick is, then calculate the density of that. You can do that as well. No one's stopping you from doing that.
Professor?
Yes.
So for me to double check for table A, as long as we use the same material for the same 3 trials, do we have to change, like if I choose brick for each 3 trials, do I need to change the mass and volume for the brick?
The mass. Can you change the volume? Yes, you can. Yeah, you need three different masses, which correspond to 3 different volumes.
Okay.
Yeah.
Thank you.
Yeah.
How do you find the final volume?
So yeah, that's a little confusing on the table. The initial volume and final volume are that of the water. So we're looking at this. We're looking at this tank of water. It's the tank of water we're looking at. So it's always 100 liters to start. So the initial volume is always 100 liters. Always, always, always. And then the final volume be after we chuck our object in there. What's the final volume? And now our final volume is 101.79.
So it doesn't matter if like the water, like if the item is like on top of the water, like under the water, doesn't matter, right?
Well, I mean, it does in terms of how much water it's displacing. You'll notice that things that don't float displace the same amount of water as their own volume, right? So the brick's volume here is 1.79 liters, and that's exactly the amount of water it displaces. When you change it to styrofoam, and I toss that in, and its volume is 1.79 liters, it only displaces 0.27 liters. So see if you can see a relationship between the volume that's displaced and the density of the material. That should have been one of the post-lab questions. That's a really good question. I should have thought of that. But that's something that, you know, if you're clever enough, that's something you would write in your results. That's something you notice. You know, maybe it's not part of the table. You know, it may not be one of the questions, but you're sharp enough to notice that there's something happening here. You would write that down. That's what, you know, a good scientist would do. You know, I noticed something. This is what I noticed, and then, you know, that's a result. And then you would do, so what an actual scientist would do is say, when I was doing this experiment, I noticed this other thing that was happening. And then you would design an experiment to follow up on that other thing. That's how you turn laws into theories, by first noticing something. It happens over and over again, so it becomes a law. And then you design experiments to explain why that is, and then it becomes a theory. So that would be a good thing to do. All right, so it's a fairly straightforward how we do that. So how you fill in table A. You're calculating the density of 1 or 2 of these materials, depending. And I think you're free to pick whatever material you want. I think it suggests wood, but you can pick any of them.
For the final volume, you said it's when our material is in the water.
Mm-hmm.
And so what that means, since it's asking in milliliters, we would have to convert that.
Yes, so you could either, you can change the table so that it's all in liters, and that's fine, or convert from liters to milliliters, one or the other.
Okay.
But in the table it says mils and you put in liters, that doesn't work, right? So if I put it in my initial volume as 100 mils, that's not true. It's 100 liters. So either make it liters or report. You have to report in the same units that it's given on your table. So your table should always have units on it, and your graph should always have units on it. Because if you put just in mass and give me a number, I don't know what that means. Pounds, grams, kilograms, stone. I have no idea what that is.
But the question, if I use liter, I should also use kilogram, not the gram. That correct?
Well, in the table, its mass is given in kilograms and grams, because they want you to calculate the density of the block in grams per milliliter, because that is generally that's the most common unit for density.
Okay.
Is grams per milliliter, because we're comparing it to water. And anyone know what the density of water is? I can hear you Googling. In fact, you should be able to figure it out by dropping this styrofoam block in there. If I drop this styrofoam block in there, which weighs 0.27 kilograms, notice how much water it displaces. 0.27 liters. What do you imagine the density of water is?
The weight of the object?
Mm-mm. Well, no, density can't be a mass.
Is it 1? A gram?
It's 1. Yeah, it's 1 gram per milliliter. In fact, that's one of the reasons why the metric system adopted the gram and the liter, is because the density of pure water is exactly 1 gram per mil. And so it makes it really easy to compare everything else to the density of water. Things that float are going to have a density less than 1, and things that sink are going to have a density greater than 1.
Last question. What do you mean about the identity of material?
Okay. Oh, which material did you use? Did you use styrofoam? Did you use wood, ice, brick, or aluminum? Yeah. So now we're going to go to mystery. Ooh, mystery thing. And see, we got 5 blocks here. And you can move them around. So the first thing you want to do is pick it up and move it over onto the scale. And then take down the mass. And
we're not table B.
Yes, this table B. And we're not given the volume. So how are we going to figure out what the volume is?
When do you find the density?
We don't know what the density is.
Would it be the difference of water placement? No.
Ah, yes. It would be the volume. It would be the volume of water displaced. If the block is completely underwater, right? If it's floating on top, it's not the entire, obviously some of the volume of the block is above the water. So let's see, so it's 65.14 kilograms. So we'd write that down, and then we dump it in the water. Oh, and it sunk. And so we can determine what's its volume? What's the volume of that block?
103.3.
0.38.
It's not 103.38.
3.38.
There you go. Yeah, it's the difference. Exactly. And this is, I mean, Archimedes was the one who actually invented this. You've heard the story about him like lying in his tub and yelling, "Eureka, I found it." Have you ever heard that story? Maybe not. He was given the task of trying to figure out, I think some king or something had a crown, and he wanted to know if it was pure gold or not. And they couldn't figure out how to do that. And so Archimedes came up with the idea that if you weighed the crown and you figured out the volume of the crown, you could determine its density, since the density of gold was known even back then. But no one could figure out how to measure the volume of an irregular object. I mean, a cube, you could calculate it, but a crown, what the hell are you going to do? And he figured out that if you dropped the crown into some water, you could measure. And he figured it out in the tub, right? When he's lying in the tub, he noticed that the level of the water went up in his tub, and he went, "Oh, if you could figure out how the volume of the water that was displaced, you could figure out the volume of the crown." And I think he was given like the crown as a gift for figuring it out or something. But yeah, so this method's been known for quite a long time. So the volume is the total volume of the water displaced. So 3.3 liters. So we know that the mass was 65.14 kilograms. The volume is 3.38 kilograms. Figure out the density, and you should figure out the identity. Now, the identity comes from here. So we're going to click on Show Table. These are the different densities of things we're dealing with. Wood, apple, we're going to have a cube of gasoline. That'll be interesting to see. Ice, water, aluminum, diamond, lead, and gold. Yeah, so you can see the water is exactly 1. Pure water without anything else in it is exactly 1. So that's why everything else is related to the density of water. So A should be one of these things. Of course, it'd be nice if you had a diamond block that weighed 64 kilograms, right? That'd be able to retire on that. All right, so if it doesn't float, let's see if we one that doesn't float. Let's look, I'm gonna put A down. Let's look at E sinks, D sinks. C doesn't sink. Okay. So if we want to figure out what the volume of this is, what are we going to do?
4.08.
It isn't. Why isn't that the volume of that cube? I can tell you definitely it's not the volume of that cube. Why not?
Because it didn't go down?
Yeah, there's still some of it above the surface. You can see it, right? So 4.08 liters is the volume of the cube that's below the surface of the water, but there's still some above it. So it's more than that. So you're going to have to push it under the water. And that's the total volume, 5.83 liters. And when I let go of it,
so for finding the values for the volume section, we have to push each cube down.
if it floats, you do. If it sinks, you don't have to. But
All right, cool.
C's density is going to be less than 1 mg per gram per milligram, gram per milliliter. And so, yeah, you're going to have to push that down. And in fact, that's kind of tricky to do in the actual lab. To do that, because when you do, if you push it down with your finger, you're also going to measure the volume of your finger. So you have to choose something that's like really, really, really small and sort of and push it down, or push it just below the surface of the water without getting too much of your finger in there. But here we can just use our virtual finger and just push it underneath.
It looks like for like each one, it's the same value, even if you push it down.
They're all the same volume?
Yeah, like for like C and D.
They're all
Like it's,
different. Well, C and D look the same, but the C, D, and A all look to be about the
oh,
same.
okay. Sorry, never mind. I was
Take
mistaken.
that. No, D's a little bit smaller. A and D look the same, look to be the same volume, and E and B look to be the same volume. But I think they're all different from each other. So A and D are one volume, C is another one, and E and B. There's like three. There should be three different volumes. Okay. So all the densities here should be in this table. Hey, Slidgy. All the volume should be in this table. If not, you can actually just look up what the volume is. Look up what the density is. If what you calculate is nothing, is none of those, you can just go to Google and type, density, 4.86 grams per mil, and basically it'll give you the best guess as to what that stuff is.
So for the density, I can calculate. I should calculate, yeah?
Yep.
Okay.
Yep, because you're going to know the mass,
Mhm.
you're going to know the volume, therefore you can determine the density.
So I use the formula
What's the formula?
for the density.
What is it?
Mass divided by volume.
Mass divided by volume, that's right. Mm-hmm.
Okay, and the last part of the table, identity of, what do you mean? Last column.
So you go to click on show table, and it gives you the densities of the various materials.
Oh, okay.
And so it should be, like I said, it should be one of these. If you don't think it is one of these, like you can just Google, substance density, 4.68 grams per mil, and Google come back with it's probably, iridium, or it's probably, this kind of wood or something.
Okay.
Because for metals, it's metal. This is one of the ways, like Archimedes did. It's one of the ways of identifying a metal. It's just based on its density. As you can see, the gold is super dense, even denser than lead. So that's actually that was one of the reasons why the king was worried, because one of the ways that people, alchemists have been trying to turn lead into gold for all this time, right? So what they would do is they would take a piece of lead and they would coat it with gold and pass it off as gold. And so that's what they were worried about, is that they had, this big hunk of gold, and 80 to 90% of it was lead. And so the way to figure it out is to determine its density. So if it was less dense than 19.3, that would say it's not pure gold. It's got something else in there.
Okay.
All right, so let's go to part 2. So part 2 has another simulation on it, and again, going to require Adobe Flash, I'm afraid. You're going to find that most computer animations are either going to be Adobe Flash or Java. Going to be one or the other. So if you're not using animations, then yeah, you're going to have to download one of them. And right now we're using Adobe because it's easier for most, not for today, but for most. So if you just click on it again, get the little finger there. If you click on it, you go to this site. And I'll just hit reset so we can make sure we're at the same place. Now it's got all of these different materials up at the top. And they're listed, some of them are listed here. And basically you're going to figure out what the mass is. Let's just grab some aluminum. It makes that obnoxious noise. And so we write down what the mass is and how we can determine the volume.
The density.
You don't know what the density is.
How it's displaced on the water?
There you go. Yeah, so we just dump it in here. So this has got water in it. You drop it in, and then you look and see, you're gonna have to, now I don't like the way that this is set up because it's hard, when you wanna read the meniscus, you've got to, your eye has to be at the same level as the meniscus. And here, it looks like you're seeing it from above rather than, see, this meniscus should be well, not completely flat, but you should be able to see directly on a straight line with the meniscus. And here we're at an angle, so it's going to be a little tricky. But what would you say that the volume is?
$1.1 milliliters.
Yeah, that looks pretty good to me. That's what I would say. 1.1. That's probably, or yeah, 1.1. Yeah, it's weird they don't have like the 1.5. Usually the 0.5 in the middle is longer than the other ones, but here it's like every even graduation is a little bit longer. So yeah, that's what I'd say. Yeah, 1.1. And you're probably not going to be able to estimate that last one from this angle. So 1.1 is probably going to be sufficient. So that's the volume. You calculate the density. And then what do you think? Do you think that floated or sunk? I'm going to hide this now. And then it asks you, or actually, show it doesn't matter. What do you think? Did that, based on the density, did you think that floated or sank?
Sank.
Sank.
Yeah, it's metal, right? It's probably, there's not too many floating metals. Yeah, so you'd say, I think it's sunk. And then you just watch, it would show you what happened. Yeah. So indeed it did. Did it sink or float? And then just repeat this for plastic, lead, candle, piece of rubber. So let's do one more, and then you guys can actually work on it yourself, and then you have any other questions. So let's dig that out of there. Or we can just hit read. I haven't been able to figure out how to go back. So I'm just going, oh, and yeah, it comes with a calculator if you want to use a calculator. And there's a table as well. So I'm just going to hit refresh. And then you just pick a different one. Anyone ever, let's just do one that'll probably float. Well, cork, we know that's going to float, right? So let's pick that one. So we got a 4-gram cork. Now I'm going to toss that in. So how much water did it displace?
8.1.
Yeah, I would say either 8 or 8.1. I think either one of them, either one of those would be correct. Because it's the problem, like I said, the problem with presenting the meniscus like that is what you're seeing is the edge of it. And the edge of the meniscus is going to be rising up along the sides of the container. And so if the edge of the meniscus is at 8.1, the bottom of it is probably at 8, but there's no way to tell because it looks completely flat, which water shouldn't be, actually. So ethanol or something like that would be flatter, but this is water. So yeah, either 8 or 8.1. Either one of those would be correct. I'd only say it would be wrong if you said 9 or if you said 7.8 or something like that. But yeah, either 8 or 8.1 or somewhere in between. That's fine. So do we think that that floated or sank?
Floats.
I would think so. Let's see what happened. Oh. Yep. Which tells us that that volume is probably not accurate, right? I guess we're probably, since it's floating, we're probably missing some of that. The volume is probably an underestimate, because just like with the last experiment we did, if it was floating, there's a little bit of the volume of that object which is going to be floating above the water and isn't displacing it. So just remember that's the volume that you measure by water displacement isn't necessarily going to be the actual volume of the object if it's floating. Okay, so does that seem fairly straightforward? Then you're just going to refresh, do the other ones, and just put in your table what the masses you measured, the volume of the water that you displaced, what the density is, and then whether you thought it sunk or float, and then whether it did.
Oh, so we have two columns for like our opinion, and then like what we think, and then we have
that's on this table it doesn't have that, but
okay.
You can include that in your results. Were there any, like when you're writing your results and your conclusions, were there any that you suspected floated but didn't? Were there any that you suspected would sink and didn't? So, and then try to explain why that is. You can just include that in your results and your discussion. If you were right all the way through, then just say, I'm a genius and I was right about all of them.
So I have a question.
Yep.
The density, like if the object's density is exactly 1, would it float or sink?
That's a good question. What do you think?
I'd say sink.
I think it would, ice isn't one of them. But yeah, ice has a density very close to 1. Very close to 1. And it floats, right? I would think that if it is exactly the same density, it would sort of just basically not float, but it also wouldn't sink. It would just be sitting there in the water, not going to the bottom. So it wouldn't be floating and it wouldn't be sinking. You know what I mean? Because it's the same density. So if you had like a piece of plastic that basically was designed to have a density of exactly 1, and you dropped it into some water, I think it would just move around the water, but it would never go to the bottom. Sometimes it would come up to the top and then it would just move back down, but it would never sink to the bottom.
So, like in conclusion, anything density less than 1 would float, and then density over 1 would sink.
That's up for you to find out.
Okay.
That's the point of the experiment.
Okay.
Professor, for the question that's below the table, do I need to include that question in post-lab report or in the actual lab report?
Oh, there is no post-lab report. That goes in the report.
No, this question.
So you would have the post-lab questions would be part of your discussion. Okay. So if you're just writing, if you're writing it separately, with all the different portions I sort of suggest that you do, then the post-lab questions would be part of the discussion part.
Yeah, but for this question, the below table.
Is density an intrinsic or intrinsic property?
Like the density of water is 1 graph
Oh, so
using
how,
the
yeah, so how would you determine if an object sinks or floats? Yeah.
Yeah. So this question, I would include the answer in lab
Yeah.
report or in post
Yeah.
lab.
Yes.
In lab report. Okay.
Yeah. That's part of your discussion. So the results would just be like, here's the data. This is the data I got. And then at the end, in the discussion part, you're explaining your data. I found that, all the things that sunk were similar in this way. All the things that floated were similar in this way. And then, yeah, answer the question. Okay. Same with the post-lab questions over here. Those could be just part of the discussion. And and these are pretty much like the questions we did in recitation. They're really, really close to those. And remember, this is due a week from today. And if it's like a day or two late, I don't want you sending me all kinds of notes like, oh my God, I'm going to fail. No, I don't get alarmed until they're like more than 2 or 3 weeks late. Once they're 2 to 3 weeks late, I get kind of angry. Not angry, I get snippy. So, people have a lot to do. People are looking after kids and loved ones and everything. So if they're a week late, I don't sweat it.
And for this lab, just table. We will not need to include any graph, correct?
Unless it asks for a graph, no.
Yeah, I mean just specifically for this lab report, no
Right.
graph. Okay.
You could, if you wanted to do a lovely bar graph of the different materials and their densities, that would be lovely, but it's not required. All right, any other questions? You can see that these online labs don't take a whole long time. So we have, 3 hours dedicated, but we are not going to use them, which is just fine. People have things to do. So yeah, so you can work on these. You can, run them as many times as you need to. If you're having trouble with Flash, let me know. We'll try and contact the computer folks in the department, see if they have any ideas about what to do. They may have a better plan as to maybe there's some other way to do these. But let me know if it's an issue.
Okay, I will try. But I have another question. For the procedure in lab report, you said just a brief procedure.
Yes. Don't give every single detail.
Yeah, but I mean, since we have three experiments, since we have 3 table, do I need to write separately for each table what we did or no?
Yes. Yeah, just really, here we basically, the procedure was, we took the mass of these different objects, and then we, put them into water to see how much water was displaced. We calculated the density and determined whether it's sank or floated. The end. That's it. Okay. That's really all you have to do. Yeah, make it brief. You don't have to go into super detail. I took my mouse and put it over the aluminum and then dragged it. No, I don't need to know that. Just what you did on the experiment. I took its mass. I measured the water displacement by putting it into the water and then determining. I read the volume off the graduated cylinder. Done.
I have a quick question.
Uh-huh.
For table A, so for initial volume, final volume, since on the table it says milliliters, but on the interactive it gives us liters. So can we just leave it in liters, or you want us to convert it?
If you write, I want you to write whatever units you want, But
Okay.
if you leave this, if you leave the units in here as milliliters and then give me liters, that's wrong, right? You can't do that. So if you want to report liters, you have to change this from milliliters to liters, and that's fine.
Okay.
I don't care if you do that. But you can do it any way you like. You just have to be truthful in what you're reporting. So if you say it's in mils, and then you say it's 100, well, that's wrong because it's 100 liters. If you want to change it to mils, then it's going to be 100,000 milliliters, right? So either way you want to do it, but just make sure that they match.
Okay, and then so when we're looking for the density of block and average density, so it's okay if we use grams over liters?
Sure.
Okay.
Sure. Yeah, just make sure that you know that there's going to be a big difference in density of grams over liters as grams over milliliters.
Okay.
Yeah, because the density of grams over mils is going to be like, around, for water it's going to be 1. Density of grams per liters is going to be 1,000. So you just make sure that you do the right calculation.
Okay.
So for the density of the block, when it's grams over milliliters, which milliliter, like which, do we use initial, final, or the volume of the block?
Volume of the block.
Okay.
Yeah. Because I mean, it's not, if it floats, the water displaced is not the volume of the block. So you can't use that volume for determining its density, right? Because that's the volume that you're determining by water displacement is an underestimate. So you would have to, I think in this, I can't remember which one floated. Was it A? No, was it D? Yeah, D is really close. D is going to have a density really close to 1. So what you would do is, remember, you just push it under the water, and then that would be the final volume.
For table A, what do you mean about average density?
You're going to do 3 different trials with 3 different amounts.
Okay.
So
then divide by 3.
Yeah, so we're going to use, so if you use styrofoam, you're going to use this much, do the calculations, and you use this much and do the calculations, then you're going to use this much and do the calculations. And you should get the same density each time. So your average density should be the same as each trial. It's basically what we're trying to show is that it's an intrinsic property. It doesn't matter how much styrofoam you get. If it's from the same batch of styrofoam, it's all going to have the same density.
Professor?
Yep.
I got a question. So, so should we turn in both the lab report and the lab form that you just showed us, like the entire thing, or?
One or the other. If you're going to do your report on the form, I still want you to have a separate section for discussion and any other results that you may have determined. If there's not a space for it in the tables, anything else you may have seen. So you would have to just write down the. Let me go back to. Yes, you'd have to have your conclusions in there and give me a brief summary. So a purpose, you'd have to have a purpose. You can put that at the beginning. So if you're planning on doing this, what I would do is just copy and paste it all into Word, and then you can move the purpose to the beginning and the conclusions to the end. If you just want to write on it, just make a space for purpose, make a space for conclusions.
Okay, thank you.
Yeah, but not both. So don't bother submitting both.
I have a question on Number 3 of the post lab, it has to show work. So how would we do that on typing? Like, do we just type it out, our work?
Or you can just write it.
Just take a picture and then just copy and paste it?
Yep.
Okay.
Yeah. Or yeah, I mean, you can, I mean, some people do, it's tough to type calculations. I can't do it. But if you want to do it, you can. Some people have, but yeah, it's tricky putting in all the, dividing lines and everything else. So yeah, you can just write that part out.
The recitation, is it difficult? Like, more difficult than this?
No, these are about the same kind of questions that were on the recitation. You weren't with us yesterday?
No, I wasn't. I stopped the time difference.
Oh, no problem. Yeah. No, the questions are about the same as these.
Okay, thank you.
Yeah. And I'll have that posted by the weekend, so you'll be able to look at it. And if it's, if you're a little late with it, it's not a biggie, not a big deal.
Okay, thank you.
Yeah.
For table A, just to clarify, we're only using one material, correct? But we just change like the mass.
Yeah, exactly.
Okay.
Just use a different mass, a different volume.
So then at the bottom of table A, identity of material, we would just put the same. Like if we're using wood.
Whatever one you used.
Okay.
Yep. Yeah, if you're feeling particularly keen, you could do another one if you wanted to. And just have trial 4, 5, and 6. That's up to you, but it's not required. And
for the average, we just add all of them together and then divide it?
I don't know. Is that how you do average?
Oh, okay. Yeah. Okay.
That's how you do average.
Okay.
Yeah.
So
cool.
Yes.
For table A, should all of the initial volumes the initial volumes should all be the same, right?
It's the initial. Yes, that's right. It's the initial. That part is confusing. I'll make sure I change that next time. Okay. Initial water volume and final water volume is what that should say. Then all the initial volume should be 100 liters. Yes.
Okay. And then for the density of the block, all my values are the same. Is that okay?
They're supposed to be.
Okay, cool. Right.
No, they're supposed to be. Yeah. If they weren't, there's something wrong.
Right.
Yeah, that's the nice thing about doing these experiments virtually is that they always work.
So then the average density are the same volumes, right?
Excuse me?
So the average of the density would be the same as the density of the block.
They should.
Right.
Yeah. But remember to use the volume of the block, not the volume of the water displaced. Yeah, I'll make some. If we're still doing this in the fall, I'm going to make some changes to this too, because it's really, I think we're missing out the fact of what determines how much water is displaced. That's really important, and we're sort of missing that in this experiment. So, anything else?
I heard you mentioned a discussion earlier. So is that like where the post-lab questions are going to be submitted?
Exactly.
Or, okay.
Yep. So the discussion should have basically a discussion of your results. What did you learn? What relations did you find between the volume and mass, between floating and sinking? Did you notice any trends? And then the post-lab questions.
Okay. Is this like posted on Canvas already, or like where do we submit that?
Yes, there should be a place to submit right now. I think I put it in there already. So let me go to assignments. And there it is. So lab report number 1, density. You just click on that, and then there'll be a space for you to submit a file.
Okay. Oh, okay. So I submit both the lab report and the post lab questions?
No, just the report.
Okay, okay.
If you're going to do your report, if you're going to print this out and do the report right on it, that's fine. Make sure you've got the discussion and purpose in there, and then submit the whole thing. But don't write two versions of the same report and submit both. I mean, I won't know which one to grade. So just submit one.
Oh, okay. Okay. Thank you.
Okay.
So
All right. Oh yeah, one more question. Sure.
the post lab is gonna be in the same area for lab report?
Post lab is part of the lab report.
Okay, yeah, got it.
It's not separate. Yeah, put it all in one.
If there's anything that we're unsure about, can we just send it to you and for you to check that we do it right?
Of course.
Okay, thank you.
Yeah. Any questions at all? Yeah, you have my email. You've got the Canvas, and if it goes to Canvas, it goes to my email anyway. So I see them in both places.
And then for table B, for finding the identity of like if you have to search up those like densities and see what like identity is on Google
Yes, if they're not part
of the table.
of the yeah. Wait a minute.
If they don't match with the table, then you have to search them up.
Mystery. Yeah. So show the table. So yeah. So if you don't see them there, yeah, just look them up online.
Okay.
Just, substance density equals blah blah blah. What is it? And you'll probably be able to find it, especially if it's a metal. If it's a pure metal, then, well, if it's a pure anything, it'll come up with a really good guess. So give me your best guess. All right. All right. I will see most, if not all of you at 4:15. All right.
Thank you.
All right. Have a good afternoon. Thank you guys.
Thank you, Professor.